Okay, hello. So in this video we'll take you through running the 2x2 mixed methods ANOVA, just so you can see the process. So hopefully you've had a go at deciding which variables your IVs, or what your IVs are from these hypotheses, and what your DV is. So we've given you a couple of hints of which variables you should be using from the data set. So your first IV is actually, say, gender, and people have either self-identified as male or female in this example. So that would be a between groups IV. You only appear in one group in this example. So the next IV would actually be type of goal, so materialistic or non-materialistic. So in this case, that's also a categorical IV with 2 levels, but this time everyone has completed a rating for materialistic and for non-materialistic goals. So that would be a within subjects IV. The actual dependent variable across this is the ratings of attainment, so a mean score for each person's perceived attainment of those goals. So that's kind of what we're looking at here. So the steps are to follow the walkthrough, replacing the examples. So this is the walkthrough. So in here we have a different scenario, but it's about using this as a guide to help you with your analysis. So there are different ways of checking assumptions in ANOVA. We're going to use the old school method here. So I'll take you through that, and I'll take you through the other steps. Okay. So we've got the data set open. It looks like this. If we go to our variable view, we can see that one of the variables we're interested in is sex. We can see that that is coded as 1 men, 2 women. Okay, now that's a between groups variable. The other variables that we're interested in, or in the data set, is the materialistic aspiration attainment mean score and the non-materialistic aspiration attainment mean score. Now this is a within subjects variable, so each of these has each person has a score on both of these, and that's why it's set out in a different way to the between groups variable. If we look at the data view, you can see that in this you've got one column, and so each person either has identified as female or male. Whereas if we scroll across to the end of the data set, you can see now each person has a mean score for attainment of, this variable, attainment of materialistic aspirations and attainment of non-materialistic aspirations. Okay, so what we're going to do is run a mixed methods ANOVA. So we go to, first of all, we've got to check what's going on with the data. So we really need to look at these by subgroup. We would first of all have to, if we go to analyze, and we'll go to explore, we want to look at our 2 variables here, so attainment and the other attainment. We want that separated out by gender. Now there are different ways of doing this, and an even more robust way of doing this would be to calculate standard deviations for each variable first, and then look at that in this way, but with the standard deviations. And I'll show you that example as well. So if we go to statistics, we can just leave the descriptive statistics on there for now. Go to plots. You have the histograms, and we want the normality plots with tests. Click continue. We just look at the options. So if we had any missing data, this is where we'd have to decide what to do with it, but we don't in this example. So continue, click OK. And what we're interested in is we're going to be looking at all of this information together. So the first thing we notice here is that the skew and kurtosis values are within ±1. That's a really good sign. You can see that the mean and the trim mean are quite close together. That's also a good sign. So we need to do that for each group for each variable. So again, that looks good. That looks good. Okay. So what we've got here, we've got now, one of the issues is that we've got quite a large sample. So actually these tests of normality can be quite sensitive. So it looks like, for example, that is not statistically significant. So that one is significantly different from normal. But so that one isn't, sorry, statistically significant from differently from normal. This one's borderline very much so. This one looks like it isn't normal, because that's a lot less than 0.05. And that one's borderline again. But because we have a larger sample size, so we're approaching 100, this can make it very sensitive to detecting even slight deviations from normality. So that isn't too concerning at this point, because our skew and kurtosis values for each variable were in plus or minus 1, which is a good sign. But we'd look at our histograms and we can see, okay, so it's not perfectly normal, but that looks roughly normal. Again, if it was perfectly normal, all of these points would fit on the line perfectly, but that's not too concerning. We've got a mild outlier, but nothing extreme there. Okay, that doesn't look particularly normal, and that one looks slightly skewed as well. But and we've got another mild outlier there. Okay, so there are a few things here that might indicate that we've got some non-normal data, but actually how non-normal we'd have to decide. So because for this example we'll go through the mixed methods ANOVA, but we can also check this using the error in the model as well, and I'll show you how to do that. And that should be an even more robust way of looking at the issues of non-normality. So we'll start to do that. Then we have to do the actual ANOVA. So go to Analyze. We'll go to General Linear Model, and we go to Repeated Measures. So what we have to do first is to tell SPSS what our within subject factor name is. So I'm going to call that goal type, and that has 2 levels, so materialistic or non-materialistic. So now I click Define, and I'll scroll down my data to get to the variables I'm interested in. So I'm interested in that one, attainment, materialistic attainment, and non-materialistic attainment. And now I need to tell it which between groups variable I'm interested in, which is our gender variable sex here. So I'll skip to plots, and I'll ask it to produce separate lines, goal types, or separate bars actually, and then sex, like that. And I'll also do it the other way around as well, so you get a sense of how graphs can, sometimes it's about playing around with graphs to get them to do what we want. So I click on bar charts, and I'll tell it to include errors. Okay, click continue. And the next thing we want to do is look at our estimated marginal mean. So I'll copy all of those across, and I'll ask it to compare the main effects. I'll apply one for any correction to that. And I'll ask it to save the studentized residuals. Let's not ourselves out. Let's do the Cook's distance as well. I'll click continue. If we look at the options, we want descriptive statistics, estimates of effect size. We should have the homogeneity test, and that should be it for now. So click continue and click OK. Okay, so the first thing we're going to do is look at that analysis for the distribution, but this time we're going to be using our standardized residual errors instead. And one of the reasons for doing this, taking this approach, is that it can be a lot more straightforward if you've got lots of IVs and therefore lots of cells in the design, so groups and subgroups and so on, and it becomes quite laborious to try and check each of those combinations of levels of each IV. So what we're going to do is actually look at the distribution of these two variables in their own right. So it's this represents the standardized residuals. So the error then in the model of our data analysis using the ANOVA, and actually we're checking this in a similar way that we would if we were using a regression, because the two are related techniques. So I go to Analyze, Descriptive Statistics, Explore, and this time we'll scroll down to the studentized residuals. We'll enter those in to our dependent list. And we're not going to try and group them this time, we're just going to look at them as they are. And if we click Plots, Histogram, Normality Plots with Tests, and then Continue, and OK. Okay, so let's have a look. Okay, so now we can start to see, okay, well, the first variable, those are within plus or minus 1. The skew and kurtosis values, as are these ones, it's more skewed. I've got a larger sample size, which is why both of these tests are probably going to return a statistically significant result. So we need to look at the histograms really. Okay, that's not perfectly normal, but again, that's still fairly skewed. So there is something kind of going on in the data, but it's not too severe. So that's kind of a moderate non-normality there. So this one is flatter than and not quite symmetrical, and this one is got more of the gradually sloping sides, but has a longer tail, so is negatively skewed. And if we look at our skew and kurtosis values, you can see that. So your skew value for the second variable is negative. So you would have to make a decision at this point whether you felt it was appropriate to perform the ANOVA. We do have at least 20 individuals in each group, so that's a good sign. It suggests that, according to Tabachnik and Fiddle, we should actually be, the ANOVA should be fairly robust to moderate violations of the normality assumption. So it may actually, we can make the argument that it's safe to proceed. One of the arguments for doing that is that there is no direct equivalent non-parametric test for a mixed methods ANOVA. So you would have to break it down by separate effects, or we could try transforming the data, our continuous variables, to see if that improves any issues with normality. And ideally what you would do is, if you do try any transformations, you would transform the data, inspect it again to see if it improves the situation. If it does, then you would rerun the analysis using the transformed data and compare the two outputs. If there isn't a substantial difference between them in the statistical significance identified, the strength, the direction of the relationships, then you could make the argument for just reporting the raw data, the untransformed data, because it's much easier to interpret. But so we won't, I'll let you have a look through your output now and try and decide what this means, but we will come back and discuss and interpret it as a group later on. Okay, thank you.